All right. This is the second question from last homework. So you can see that I've labeled according to color. We're going to go ahead and graph these inequalities. Let's look at the first one. We can see that the first inequality is already written in slope-intercept form, so I don't need to do any manipulations there. I'll just leave that as it is. The second one, I know some of you would probably like to use x and y intercepts and then use a test point. You could do that, but you can see that y is going to be very easy to isolate here. So let's go ahead and do that. We'll write in green. So I have this inequality, 3x plus y is less than or equal to 5. All I need to do is subtract 3x, and I'm going to have a y isolated. So y is less than or equal to negative 3x plus 5. Okay, so we're almost there. We take a look at this inequality here. We can see that, again, it's going to be pretty easy to isolate y. Let's go ahead and write that out here. X minus y is greater than 0. So if I subtract x, I'm going to isolate negative y. So x is greater than, sorry with that. Negative y is greater than negative x because I subtracted x to both sides. So if I multiply or divide both sides by -1, I'm going to have y isolated as y. So when I do that, I need to change this sign here. Otherwise, everything's going to be different. So y is going to be less than x. Okay. So now we've got all of our inequalities ready to graph. They're all in slope-intercept form. Except, So let's go ahead and do that. Green, starting point is at 5. So our starting point is at 5, and I'm going to have a negative, sorry, that's not green. Okay. And I'm going to have a slope of -3. So I'm going to go down 1 and over, down 3 and over 1, pardon me. Okay. So I can go down 3 and over 1 again. Okay, so we're going to have this slope. And if we look at this, we can see it's equal to. So that's going to be a solid line. It also includes the line itself. All right. Now, since y is less than or equal to, we're going to shade below the line in that case. So have a look at that. Shade below the line. Okay. Looking at the next inequality, it's simplified out to y is less than x. So think about that. What is the starting point? Well, there is no y-intercept. Well, it's 0. So its starting point is at the origin, and the slope is 1. Okay, so that one's pretty easy. We're going to go up 1 over 1. And so we've got this, and it's going to be a dashed line. Okay. So it's going to go through the origin, like so. And where is it going to be shaded? Well, it's less than, so it's going to be shaded below the line, okay? And now we have one more inequality to look at. The original one here that was in black. Okay, so let's go back up here. This one was already ready for us. Slope was at 7, and the starting point at 3. It's going to be greater than, so that is going to be a dashed line. Okay. So again, we said the starting point was at -3. So 1, 2, 3, starting here. It's a positive slope, so we're going to rise to 7. 1, 2, 3, 4, 5, 6, 7, and a run of 1. And that is a dashed line again. Quite steep, actually. And then when we go to shade that, it's going to be greater than. So we are going to be shading above the line. That doesn't look very much like a slope of 7. We're going to shade above This one's a little bit harder to see. Okay. Now we're going to look, where is that feasible region that satisfies everything here? Okay. And we can see that, well, this area here, it does satisfy the green and the red, but it doesn't satisfy the black line. Okay. And so the only place that it satisfies everything would be at this point here, where we can see this is going to satisfy everything. Okay, because that green actually keeps going all through here. Okay.